What is indefinite integral? How is it related with differential equation? What is differential equation? All these questions will be answered in this particular video, and then you'll have a great foundation to begin with integration. Let's enjoy the journey of learning with Anil Kumar. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. With this video, we are starting a new series on integration. This series is especially for my IB students. Now you start learning about integration, we have to go back and look into derivatives and see how they are connected. For a very strong foundation, I have prepared this special series for all the IB students. We'll begin with understanding the basic concepts about indefinite integrals. Why are they called indefinite integrals, and how do we physically see or visualize them? That is a very important concept. And of course, family of functions with vertical translation, as you can see here, relates to the indefinite integrals. How is it so? Indefinite integrals means writing this f of x dx equals to the f of x plus c. That constant c plays a very important role. And all the time when you're finding an integral, in that case, you have to write c. Otherwise, you lose 0.5 marks. We are very specific about writing correct solutions so that you are able to achieve 100% success. Then we'll have solutions of questions related to specific solution with initial or boundary condition given to us. In that case, we'll find the value of c, and therefore you will have a very specific function for which the derivative was given to us. Integration of power function, very simple to relate, and therefore we'll just begin with that. In following videos, we'll understand different rules of integration and then explore it further. With that, we'll have some practice test questions to get you started. So this part of our video is for you to understand the concepts and get started with integration. So let's look into indefinite integrals in more details with some basic examples that should form a foundation for you. So let us explore some derivatives, right? So I'll write down the derivatives of few functions. As you know, if I take y equals to, let us say, x cubed, in that case, what is dy dx? Well, clearly, the dy dx, you know, is 3 times x squared. So to find the derivative, the exponent is multiplied by the function and then the power is reduced by 1, right? That's a general rule. Well, let's further explore. If I have the function x cubed, let's say, plus 10, in that case, what is the derivative? Well, clearly, the derivative still is 3x squared. Reason is simple. For any constant, the derivative is 0. Okay, how about y equals to x cubed plus some constant k, right? It could be any value, any real value, plus or minus, right? Well, definitely, as we are saying, that the derivative is going to be 3x squared. Very simple, because the derivative of the constant is 0. And the reason, as you know, is that d dx of any constant k is equal to 0. Correct? Now, what does that mean? That means that all these functions which form a family of cubic functions, right? So this is the family of cubic function. Let's write x cubed, right? So a family of cubic function which is translated up or down based on the value of k has the same derivative, right? So this is your cubic function shown on the right hand side. So this function is one which is the base, the parent function, where the constant k is 0. And here the constant k has a value of 3, and in this case it has a negative value, -1, right? That is -1. But you see, all these graphs are very similar. So what you notice here is that if the gradient of the function is same, then the functions are parallel and are translated vertically. Do you understand? This dy by dx is actually giving you the gradient. So if the derivative is same, slope at every point is same, the gradient is same, then the function which we are finding derivative of belongs to a family which is vertically translated as you have seen here. Perfect, right? So let's move on and see. Can we do the reverse operation? That is to say, can we get the function itself from the derivative? Well, let's look into that part now. So what we just explored is that if y is equal to x cubed plus any constant k, right? So where k belongs to the set of real numbers. In that case, we have the derivative dy dx as equal to 3x squared. Since the derivative of a constant is 0. And we have seen that this is the family of curve which is belonging to x squared, x cubed plus, let me rewrite this, right, which belongs to the family of x cubed plus k, whose derivative is 3x squared. Now if you look at this equation, we call this as a differential equation. Let me write down here, this is called differential equation. So introducing you to some new words. So keyword, differential equation, mainly because the equation has derivative involved, right? Because of this differential dy dx, right? Okay, now the idea here is to find the function whose derivative is given to us. We know if derivative is 3x squared, the question here now is if derivative is 3x squared, what is the function? You get the idea. We want to find what is y when 3x squared is the derivative. Well, that's critical. Well, as you have seen, y could be x cubed or family of curves translated vertically. So in this particular case, we know that y is equal to x cubed plus the family of curve which is translated up or down. So that means when we go back, we have to add a constant, arbitrary constant. We don't know what is the value of this constant, right? So that is something which we see while going back from the derivative to the function. You get the idea. Let us summarize these key concepts. Okay, so what we have learned just now is that the derivative of y equals to x cubed plus k is dy dx, which is 3x squared. Reverse of this differential equation, this is called the differential equation. Reverse of this differential equation, the function with derivative of 3x squared is x cubed plus c. That constant we'll now call c, capital C. Since the derivative of a constant is 0, that is the reason why we have such a situation. So you have noticed that by reversing differentiation, we are able to provide general solution. So that becomes a general solution of the differential equation dy dx equals to 3x squared as y equals to x cubed plus c, where c is arbitrary constant. Right? So now onwards, when we go reverse direction, we'll use c, capital C, which will be called arbitrary constant. In our examples, we will see how to find that specific curve, right, or arbitrary constant from given conditions. So here's a note for you. If the gradient of function is same, then the functions are parallel and are translated vertically as shown in the graph here. Is that clear to you? Perfect. So you're with me, right? Well, in case you want to learn from me, you can always send an email on the address given. Feel free to write your comments and share your views, and also check our website for the latest updates and offers. Right, so let's now continue from here. So what we really found is that there are many curves to choose from, and we don't know which one is the right curve. So this example will help you figure this out. Now the question for you is, given dy by dx is 3x squared minus 2. We just changed the question a bit, right? Given dy dx is 3x squared minus 2, find the equation of the curve with this gradient function which passes through the point 2, 1. You get the idea. So we have given you a condition, and that condition can help us figure out the specific value of the function whose derivative is given to us. You get the idea. Right. So let's look into this solution now. So we are given that the differential equation is, which you say derivative dy dx is 3x squared minus 2, right? So what is y? So we call this as an integral. So reverse, right? So what is y? The question is, what is y? Right? So we have to figure out what is this value of y, which gives us the derivative of 3x squared minus 2. Well, you remember, when you find the derivative, what you really do, right? So it looks like a power function, right? So if you know x to the power of n is there, right? So if you want to find the derivative of x to the power of n, what do you get? You get n times x to the power of n minus 1. Now in this situation, we are given the output, right? We are given n times x to the power of n minus 1. How do I get back to the function y? Perfect. So we have to do the reverse operation, right? So we have to do the reverse operation. Correct? So just as we did earlier with x cubed, we got 3x squared and went back and we got x cubed, right? Okay. So now, so y can be treated as equal to, we are given this function 3 is a constant x squared. So instead of subtracting, we will do the reverse operation of adding 1, and instead of multiplying, we are going to divide by 2 plus 1. Does it make sense to you? And minus 2. So minus 2 means what? We got the derivative as minus 2. That means there must have been just x there, right? So we have 2x, correct? Also, we notice that there is a family of curves vertically translated. So we have to add our arbitrary constant c. Perfect. So do you see this? Now, I would like you to actually find the derivative of this function and check for yourself. Do you get what was given to us, right? So let me rewrite this. We got our answer. So let me rewrite this as, so 3 and 2 plus 1 is also 3. It cancels. So we get x cubed minus 2x plus c. Correct? Now to find the value of c, what are you going to do? We are going to utilize the information given to us. The function passes through the point 2, 1. So if I substitute x as 2 and y as 1, I should get the value of c. Correct? So that is what it is. So I'm going to do just that. So it goes through a point P, which is 2, 1, right? So I'm going to substitute the values. So I'm writing 1, the y value, is equal to 2 cubed minus 2 times x is also 2, okay, plus c, right? So, okay, so that gives you 1 equals to 8 minus 2 times 2 is 4 plus c, or that gives you 1 equals to 4 plus c, right? So clearly from here, we know c is equal to what? C is 1 minus 4 or minus 3. So you see, we found the value of C. So no more just a general solution, right? So nothing indefinite about it. You get the idea. Now we have a specific curve to work with. So I hope you have connected the dots, right? So now we are saying that the value of y indeed is x cubed minus 2x minus 3. So out of those functions which were translated graphs, we are in a position to specify which one really we are looking into, the one which passes through this particular point. And therefore, we have seen how do we find this specific solution when there are infinitely many solutions for a given differential equation. So can I use this language now? Differential equation, right? This is called the differential equation. And we did the reverse, and I'm going to use the word integration is the process of this reversal, right? So let's summarize. So here is the solution with the diagram, correct? So once again, the differential equation given to us is 3x squared minus 2. We needed to find the equation of the curve that passed through 2, 1. So we find the integral, right? So integral was 3x squared minus 2 was x cubed minus 2x plus c. The arbitrary constant c was then calculated by substituting the value 2, 1. And you can see here the graph, that is the point 2, 1 on the function, right? So have the value of y, and that is how it could be represented, correct? So important to note is that the arbitrary constant can be evaluated with some additional information as given in this particular question. Perfect. Now let's get back to our learnings, right? So what did we learn? Many new terms were introduced to you, and so let's look at these terms, right? So instead of y, I'm writing f here now. So df dx equals to a function f of x. Now this part is like a differential, right? Derivative of capital F with respect to x. Perfect. So the given equation contains a function and their differential. So this is the function and their differential. It is called differential equation, right? So we call such equations as differential equations. To solve differential equation, df dx equals to f of x is to find an expression for capital F as a function of x. That really means to undo the differentiation by means of inverse operation called integration. So integration is the reverse operation of derivation, right? So these are both related, correct? So now we can summarize. Df dx equals to f of x implies that you can find f as the integral of f of x dx. That's the way we'll be writing the integral. So let's try to understand this particular part of the equation. So here the operation of integration is denoted by the symbol given to us, right? So that is the integral, right? And that is the operation of integration as a whole. The function f of x to be integrated is placed between the integral sign, so that long s, stretched out s is the integral sign, and the differential dx. You see? So that is what the function f of x is placed, right? Okay. And this function f of x is called integrand. So this function f of x is called the integrand. And how do we say this or read this equation? Integrate with respect to x. That is how we say, right? Okay. So I hope now we have summarized what we just learned with some technical terms. So a differential equation is given to us. Finding capital F from the derivative given to us is the reverse process of differentiation and is called integration. Correct? Perfect. Now, let's take up examples to consolidate our learnings. I hope you are with me, right? These are 3 questions for you with slightly different language, but they all mean the same thing. I'd like you to pause the video, answer these questions, and then look into my suggestions. Well, in case you want to learn from me, feel free to send the email. Now, question number 1 is find y, right, for dy dx equals to x to the power of 5. So this is a differential equation. We are given the derivative. We want to find y, the function itself. Clear? Second, find f of x for derivative of f of x equals to 1 over square root x. Clear? And then the above language is written in the integral form, the formal language which we are going to use now onwards. Find the integral x to the power of minus 4 with respect to x, right? Now these are the rules which are just reverse of constant power function derivatives. So we have just reversed it, right? So you know that dy dx of x to the power of n is actually what? N times x to the power of n minus 1. When we do the reverse operation, then finding y, reverse the operation. So exponent is added and is divided by n plus 1 plus c, correct? So that is how it is. Okay, so let us answer these questions. I hope you have already answered them. So y for dy dx equals to x to the power of 5. So we can write y as a reverse operation. After all, what will this be? We have to add a power, do the reverse, right, and divide. So that becomes the operation, and don't forget to write c, correct? So what you can do here is also check your result, correct? So if you want to check the result, find the derivative. So what is the derivative of this? Will be 6 times x to the power of 5 over 6 plus 0. You see that? And of course, this 6 and 6 cancels, and what you get is x to the power of 5. Perfect. So it matches. Perfect. So do you see both ways it matches? It's a good idea since you're starting to check your result, right? Next one. We are given the derivative, and this time the derivative given to us is 1 over square root x. Let me write this as x to the power of minus half, right? One and the same thing. So now, what is the value of the function itself? So from derivative, that means differential equation, we are coming back to the derivative, means doing integration. Okay, so we are going to add the exponent, so it is minus half. We'll add 1 to minus half here and divide by minus half plus 1. Makes sense, right? So when you add, you get x to the power of half over half, correct? Or we get our answer, which is 2 times square root of x. You can check the result. The derivative of 2 times square root of x will be what? Half of this times in the denominator square root of x. So yes, you get it. Okay, the last one here. But there are many more to go. Okay, so there are 10 questions in this particular video which we are going to discuss. Question number 3 here is that the integral x to the power of minus 4 dx, you have to calculate this. Well, this integral should be equal to what? X to the power of minus 4 plus 1, correct? Divided by minus 4 plus 1 plus c, right? So don't forget to write c. Let me add c in the previous case also, right? Okay. Fine. So now, what do we get? We get x to the power of minus 3 over minus 3 plus c, and that clearly is negative 1 over 3x cubed, right? So that is how we are going to find the solution of these 3 questions. So let's move on. Here are the solutions neatly typed out for you. You can have a good look at it. Perfect. Now we are getting into slightly more complicated ones. Question number 4 and 5, 6 and 7 will be even. Slightly more different functions, okay? So be with me to appreciate all this. So if I have integral of 5x to the power of 4 plus 3 dx, what will that be? Well, that integral is going to be 5 is just a constant, right? And x to the power of 4, add 1, right? So I'm adding 1, writing 5 here, dividing by 5, plus 3, and that is like x to the power of 0, right? 1. But now we are going to add 1, divide by 1, we get x to the power of 1. No need to write 1 though, okay? But x is important. Plus c, right? So that becomes the integral. And now let's simplify, cancelling 5s. What do we get? we get x to the power of 5 plus 3x plus c, correct? Let's do the next one. 3 over x square, right? So this could be written as integral 3 x to the power of minus 2 dx, correct? So that is equal to, so 3 is a constant, right? X to the power of minus 2 plus 1, correct? Divided by minus 2 plus 1 plus c, right? That gives us, this is what? Minus 2 plus 1 is minus 1, right? So we have minus 3 x to the power of minus 2 plus 1 is minus 1. And therefore, the answer is minus 3 over x plus c, right? So let's write plus c here, correct? So this plus is actually afterwards. It's not in the denominator, right? Don't get confused about it. Let me write big and bold. So that is how we are going to write down the solution. Okay, so we are midway between our solutions of these questions 6 and 7, 8, 9 to follow. So now we need to find the integral of sine x dx. So what is the integral of sine x dx? Okay, so is it cos x or minus cos x? So that is a big thing. You know, cos x derivative is minus sine x, right? So we know that d dx of cos x is minus sine x. Is it okay? So the reverse should be minus cos x, correct? Plus c. So that is our answer. For secant square x, it is tan square x, which you know. So we'll just write it down along with the constant, arbitrary constant. Let's move on and take the next set of questions. Here we have exponential functions and the radical function. So e to the power of 2x has exactly the same derivative, right? So we'll have this integral e to the power of 2x dx as equal to e to the power of, add one power to it, correct? So e is the same thing, right? And then, you know, the derivative of e to the power of x is the same thing. So divide by 2, right? So that is what it is going to be. So it is plus c, right? Plus c. So we could write this as half e to the power of 2x plus c, right? You remember that the derivative of e to the power of x will be, let me write x for now. We can use the power rule to get that, right? So that is, okay, nx will be what? Okay, let's write down. E to the power of nx, general term, right? So will be n times e to the power of nx, because the derivative of exponential function is exactly same. Okay, now here we have integral of x to the power of 2 by 3, right? Dx. So this is equal to x to the power of 2 by 3 plus 1 over 2 by 3 plus 1, correct? Plus c, and that is, we got x to the power of 5 by 3 over x to the power of 5 by 3 plus c, correct? So that is how we get these solutions. The last question comes for here, and this is very important. It says, find the function f of x that satisfies the condition that the derivative of the function is 3x squared plus 4x and f of 2 is 20. So we are given a condition, we should be in a position to find the value of arbitrary constant and therefore a definite value of our integral, right? Indefinite integrals have many solutions, plus c gives you that variety. Okay, so we are given here that the derivative, that means d dx of a function, is equal to 3x squared plus 4x. Okay, so in that case, what is the integral? So original function is what? So original function will be, so we have 3 here, x to the power of 3 divided by 3, correct? Plus we have 4, x to the power of 2 divided by 2, correct? So that gives you 3 and 3 cancel, x cubed plus 2 x squared, correct? So that becomes the value of f of x in general plus c, right? So let me write down plus c. We'll now find the value of c separately from the given condition. So the condition is that f of 2 is 20. So when I substitute 2 for x, we get what? So we get f of 2, which is equal to 20. Let me substitute 2 in the equation given to us, which is 2 cube plus 2 times 2 square plus c. Makes sense, right? So that is how it is. So we can solve for c now. So we get 20 equals to 2 cube is 8. 2 square times 4, 2 is also 8, right? So we have 8 plus c. So we can write down 20 minus 16 equals to c, which is equal to 4, correct? So we find the value of c as 4. Perfect. So let me write down the answer that c, the constant, is equal to 4. Correct. So with that, we end our first video on understanding what is indefinite integral. So we began with a differential equation, and we understood that any differential equation where there is a constant, derivative of that constant is a 0. And therefore, when we are doing the reverse calculation, in that case, we lose the value of that constant, right? So the idea here is that if I have a function here, we are finding dx, right? Derivative of a function, which is, let us say, f of x plus c, right? Let's say constant k. So what we get here is the derivative, right? Of course, where k is lost. Correct. And when we do the reverse calculation, which is called as integral, in that case, what happens? We get the function itself and we have to write arbitrary value of c. Since we don't know what is that k, to get the specific value of k, we have to have an initial or a boundary condition, right? As we had in our example number 10, and also right there in the beginning when we explained the concept. So the idea is that the derivative, when given to us, could represent any of these vertically translated functions. In fact, there are infinite of these, right? So these are infinite combinations, right? Possibilities, right? Since there are infinite, we call this as indefinite integral. That's how it gets its name. And arbitrary constant c is a very integral part of it, which you should not miss in your calculations. Given initial or boundary conditions, you can always find the value of c. So that is how we'll summarize this. And now we will learn different rules of integration and then take up many examples based on indefinite integral, definite integral, fundamental theorem, and more. Thanks for your time and all the best.